Hello friends, welcome back to TechnoSkillUp, your pathway to upscale. Today we are going to learn about stop and wait protocol. If you are watching this video directly, I strongly recommend to watch my previous videos related to various network relays and basics of data flow control so that you will be able to understand this topic easily. I have provided the links for those topics in the description box. Please check. From today's topic, we will learn the working of stop and wait protocol. We will do deep dive into this technique and we will do a thorough analysis of the topic so that after the completion of this, you will be able to solve the problems related to this protocol. If you like this video, please hit the like button and share this video with your friends and colleagues. And also, please do consider subscribing to this channel and do not forget to hit the bell icon to get the notification for all my upcoming videos. Stop and wait protocol. As you know, it works under noiseless channel where we consider that channel is perfect and there is no errors during the transmission of the packet. Let us now understand how it works. Consider this is the sender timeline and this is the receiver timeline, and sender sends a data packet to the receiver. After sending this data packet, sender will stop and wait for the acknowledgement from the receiver for this sent packet. Then receiver receives this data packet and processes it. After processing, receiver sends the acknowledgement packet to sender. After receiving this acknowledgement packet, then sender will send another data packet and will stop and wait for the acknowledgement from the receiver side. Now do an analysis for stop and wait protocol. Consider this is the sender timeline and this is the receiver timeline. We want to send this data from sender to receiver. So this is the data packet. So as we know, the time taken to put this data into the transmission medium, this is the TT, transmission delay, and this transmission delay is for this data. So it will take some time to reach at the receiver end. So the time taken to reach at the receiver time, this is the propagation delay, and this propagation delay is for data. After reaching this data at the receiver side, this data will be in buffer for some time. So that delay will be queuing delay. And after this queuing delay, it will take some time to process the data, and this is the processing data for delay for this data. And after the data will process at the receiver side, it will send the acknowledgement packet. Again, for putting this acknowledgement packet in this transmission medium, this delay we consider as transmission delay for the acknowledgement. And when this acknowledgement will reach at the receiver side, the time taken to reach at the sender side, this is called propagation delay for the acknowledgement. After reaching this acknowledgement, sender will process this acknowledgement. Before processing, this acknowledgement will be in queue. So likewise, this has a queuing delay and the processing delay. Now we will calculate the total time taken in sending one data packet from the sender to the receiver. So the first delay is the transmission delay for data plus the propagation delay of data. After reaching this data, there will be queuing delay and processing delay. And then again this transmission delay of acknowledgement and the propagation delay for acknowledgement and queuing delay for acknowledgement plus processing delay of acknowledgement. As we understand from our previous videos that queuing delay we normally consider as 0 and processing delay we consider as 0. So considering these two delay as 0, so we have the total time is transmission delay for data plus propagation delay of data plus transmission delay of acknowledgement plus propagation delay of acknowledgement. We can consider here the transmission delay of acknowledgement is 0 because acknowledgement packet is very small. So obviously if the packet is very small, then the transmission delay is considered as 0. So now we can write it as the total time taken is transmission delay of data plus propagation delay of data plus propagation delay of acknowledgement. As we are using the same medium, then the propagation delay for data and the propagation delay of acknowledgement should be same. So it is TT plus TP plus TP. So we can consider it as transmission delay plus 2 TP. So the total time taken is, total time we can consider is TT plus 2 TP. Now we will calculate the efficiency. So the formula for efficiency is useful time divided by total time. So in this protocol, useful time is transmission delay divided by total time is transmission delay plus 2 TP propagation delay. So let us consider dividing transmission delay with transmission delay divided by, so if you divide this one plus 2 TP by TT is equal to 1 upon 1 plus 2 TP by TT. We can write it as 1 upon 1 plus 2A, where A is equal to TP divided by T. So efficiency is equal to 1 upon 1 plus 2A, where A equal to TP divided by TT. Please remember that we also called efficiency as link utilization, sender utilization. As you know, efficiency is 1 upon 1 plus 2A, that is 1 upon 1 plus 2. A is TP divided by TT, that is equal to 1 upon 1 plus 2 multiplied by TP. TP is distance by speed and TT, transmission delay, is L by B. As it is divided by TT, then we can write it as B by L. So now what are the factors affecting the efficiency? Efficiency is directly proportional to the transmission speed, and it is also directly proportional to length of the packet. As you see, it is inversely proportional to the distance between sender and receiver, and also inversely proportional with the bandwidth. Let us now calculate the throughput. Normally, throughput, also known as bandwidth utilization or effective bandwidth or maximum data rate possible. So the definition of throughput is number of bits that can be sent through the channel per seconds. That is called throughput. So mathematically, throughput is L divided by total time, that is transmission delay plus 2 into propagation delay. So if you divide this with bandwidth and multiply with bandwidth divided by Tt plus 2Tp. So as we know, L by B is transmission delay multiplied with bandwidth divided by Tt plus 2Tp. So if we write this as Tt divided by Tt plus 2Tp multiplied by bandwidth, that is efficiency is Tt divided by Tt plus 2Tp multiplied by bandwidth. So throughput is efficiency multiplied by bandwidth. Now we will discuss about the limitations of stop and wait protocol. So the first limitation is it is inefficient because it makes transmission process very slow, and it never used bandwidth entirely, as only single packet and acknowledgement uses the entire time to traverse through the medium. The second limitation is when the data packet sent by the sender get lost. Let us consider this is the sender and this is the receiver. So when sender sends a data packet, for example, this is sending a data packet, and this data packet is lost due to some reason in the medium. So if this data packet will lost, what this receiver is waiting for? This receiver is waiting for this data packet. It is waiting for this data packet, and also after sending this data from the sender also waiting for the acknowledgement packet from the receiver. So it is kind of a deadlock situation for both sender and receiver, because they are waiting for their respective packets and they will wait forever. So this is kind of one limitation if the data packet will get lost in the medium due to some reason. And accordingly, for example, this is sender and this is receiver, and when the acknowledgement packet will lost, for example, data packet it will receive, receiver will receive, and while receiver sends the acknowledgement packet, it will get lost. So in this situation also, sender actually waiting for the acknowledgement packet for its sent packet, and after receiving this acknowledgement packet, receiver also waiting for another data packet. And they will wait for their respective packets forever, and it is also a kind of a deadlock situation. So these are the three limitations for this stop and wait protocol. Let's end today's videos here. I hope you learned something new from today's video. Next we'll learn other sliding window protocols in our upcoming videos. Please motivate me by subscribing to this channel. Thanks a lot for your time. Thank you.